The company started in the late 1970s. We were mining at the time, doing some leaching of a complex ore. From there we got into amalgamation, and we were doing fire assaying. We started selling our equipment, supplies, and information through a catalog around the world. We started teaching seminars in the 80s and started our magazine, Popular Mining. From there it just kept growing, and we kept selling more things, and came over to Vegas from California, and things have been going real well since then.
There's three adjustments. We have a water flow. We have how hard the table actually hits, and then we have the tilt of the table. The water flow is to make the ore move. We don't care if it's real clean water as long as it's not so dirty that it's interfering with the flow of your ore. So that just a simple screening operation and a recycling of your water is very good. You will lose some of your water because of wetting of your ore, but most all your water will be recycled and used over again. The adjustment of how the table bumps or how hard it actually hits, which is what pulls the gold to the top of the table for our concentration line, is as little as possible. What we're trying to do is bring it to us, not hit it real hard, because the bump is not to drive the gold. The bump is actually just to move the gold. If you actually drive the table too hard or hit the bump too hard, it actually forces the gold to go in the opposite direction. Is not good. And then the tilt of the table, how high the back of the table or the end that you actually feed the ore in, which you also take off your concentrates, is higher than the discharge end, which is where your tails come out. In production, we're looking at running approximately 1,500 to 2,000 pounds an hour. With that, your table tilt is somewhere between 1 and 2 inches. That's regulated by how much concentrate you want, how heavy they are, this type of things to which you will be testing to find the concentration level you need. The other is when you're just running testing or you're running high-grade concentrates where you're only running maybe 5 pounds or 5-gallon bucket of material. You will then be running upward between, let's say, 4 and 5 inches, concentrates out of Alaska, black sands cons, 5.5, 6 maybe, black sands out of North America here. Normally we run them between 4 and 5. Magnetics somewhere between 5 and maybe a little higher, just depending on what they are. The way it's set up now is when you actually first get your table, you have an adjustment for your legs are adjustable, your water flow is adjustable, your bump is adjustable, and you would use it as is. When you go to production, there's actually counterweights, so you add weight to the counterweight, which actually makes the table drive harder. They are not to be used until you are in a production operation. If you use them before then, the table really hits way too hard for the amount of weight that's on the table. The tabletop itself is made out of fiberglass. It's a marine resin. We have never had anybody wear it out. We've had people that dropped way too big rocks on it and crack it. But all of those things are easily repaired. You can even take them locally to anybody that actually works with fiberglass. Tell them to get a good marine grade can't think of the coat, a blue coating, gel coat, a marine grade gel coat. What they have to do is sand the table down, the inside of it, and spray it very carefully so that they have a nice smooth surface. After they're done, you will wipe it down with acetone, and then you'll take a 200 mesh sanding to it and sand the whole table down, the inside of it down, so it's nice and smooth and rough. You will not want to leave the gel coat on there unsurfaced because A gel coat is actually got oils in it, and it will skim over, and then you'll have an oil in it that you need a roughness for that gold to move with. The table actually works on linear bearings, which keep the table going up and down, does not allow it to shake and move around in any direction that we do not want, which is one of the reasons that the table has to be bolted to the ground very securely so that it is not moving. The only moving part that you want on your table is actually the tabletop itself going back and forth. Patent pending on the action itself is in patent pending operation. Like I said, it's a refinement of some old operations. The patent pending is basically set up for the mechanical driving of it itself. The M7, well, let's start at the M4. M4 is the smaller lab table, runs on 12-volt batteries, or 12-volt electricity DC. Can be run from a car if it had on a trailer. The M7, the patent pending parts are your linear bearings and how it's set up, and the offset weights, the ways it runs. The M10 sets on linear bearings, is run by hydraulics, so that you have a very fine tuning that you can do with the M10. The M10 is actually is made for primary concentration. When you're running 5 to 8 tons an hour, testing 100 pounds on the M10 will not really work at all because it's not set up to even set up to be able to do that. Now, the M7, M10, when we're making a concentration, it's normally more cons than under normal circumstances that most people are looking at. We're looking for maybe a 10-to-1 cut on a first pass of an ore. That means that if you run 2,000 pounds, you have 200 pounds of concentrate. Now that sounds like an awful lot of concentrates, but it doesn't mean much to us because the table will run 200 pounds in about a half an hour and you've got all your gold out of it. What your primary concentrate is to knock down the bulk of your material and make sure that you have all of your gold in a concentrate. We consider a 70% to 75% is a good commercial recovery system. We are normally looking for somewhere between 85 and 90% recovery on our commercial operations. But to do that, like I said, we're running a lot more concentrates and then rerunning them on the M7 table. Like I said, that once set up in a line, it makes it real easy. You'll not even notice your concentration levels because of its flow through. The M7, or all of the tables, they're primarily made for microscopic gold. That's what we got started with in the business. And we're talking about gold that's 120 mesh and finer. We have commercial operations that are separating at 5 microns. It's a special operation. They're actually collecting silica carbide crystals at 5 microns. They get about a 98% purity at 5 micron. Any finer than that, they start getting too much. They have to have the 98% purity. Most tables are not actually there are any of your gravity feed mechanisms that are out there. They will collect a small percentage of that, but the problem that they have is that you cannot separate that fineness from the bulk of the concentrate. With us, we can actually separate that fine microscopic gold out of anything that comes along to a point to where we can make a commercially valuable product. We don't only just do the gold. We also, like I said, we have companies getting silica carbide crystals, tungsten, with scheelite, zinc oxides, and we have a plastic manufacturer that actually is collecting what their product is the plastic, and what they're trying to do is get all of the sanding media that they use to grind up to actually sand off the paints and the plastics off of airplanes. They're trying to separate that from the plastics. They need the plastics. They want to get rid of the grinding media. In that case, in gold, our specific gravities are going to the top of the table, and our tails are going to the bottom. In a case like that they're plastics and trying to separate the heavy sand media out of it. Their product is actually in our case, would look like the tails. In other words, they're going out the bottom end, and all the trash is going out the top end. But primarily, we got started, like I said, we got started on the microscopic gold, or the gold that was 120 mesh and finer, to get to a concentrate that you could smelt and make a concentrate out of. 10% by weight is normally a sellable product. In other words, if you have a pound of material and you have about an ounce and a half of gold in that, this is a sellable product. You can then take that and either smelt it, make a dory bar out of it, or there's refiners that will buy it at that stage. And with our tables, we can do that. We can take that fine gold, separate it from the bulk of their concentrates, and make it a sellable product. And do it quickly and easily. There have been a couple of improvements over the years on our table. The basic mechanism of it is stayed the same, the linear bearings and the shafts and the weights. The bigger tables under the hydraulics. But we've added we call it a hydraulic riffle bar. You'll see that in the demonstration of the table running, which forces the slurry to run faster through the table. Now, the other thing that we've added, and it's on the big table, the M10, and you do get it with the M7, is a matting with V grooves in it. Now, the V actually goes the length of the table, and what it's for is, in the small, the M7 primarily is for like plaster operations where you're actually screening and not grinding. What that does is it lets the ultrafine product that you're trying to collect get down in the bottom of the V so that you can run bigger material without fear of losing the fineness, because what it does is the V lets the fine material get down into the groove, and the larger stuff stays at the top of the V so that you can run larger material with your finer gold. And on a big table, it is put on a table. It's set there. It's put in there so that in a production operation, there's always bigger material that gets through your screen. It's just one of those Murphy's laws, and how it does that, we do not know. But that keeps that from having a problem. In other words, if a quarter-inch rock gets on through your material to the table, that quarter-inch rock is not going to affect the recovery of your fine gold, because it cannot get to it. It cannot get to it and hit it, because when you're talking microscopic gold, you start talking down to 200 mesh, 300 mesh gold, 5 micron. If you're looking at a piece of sand and you can actually see that piece of sand and feel it in your fingers, and you throw it on a table and you get it mixed in with the fine gold, that piece of sand is heavier physically than that 5 micron, 10 micron, 100 micron piece of gold. It will move the gold, and that's not what we want. So what we have is that grooves, and that makes that takes care of that problem, and makes it more forgiving for the customers that are actually running the tables. Precision mining table. It is a very cost-efficient and technically one of the least technical type pieces of equipment In other words, you don't need to be very technically inclined to be able to run it. Once it's up and running, once everything is running, you can leave it alone. You can leave it as long as everything, all the rest of your equipment is running, leave it alone and it'll run by itself. The other options you have are leaching, flotation cells, amalgamation. Now, we sell and have proprietary formulas for leaching. We have amalgamation equipment and have proprietary formulas for amalgamation. For technically involved or how technical you need to be, the top of the line is leaching. It's a very technical, intensive type of operation. You cannot leave it at any time. You have to stay right on top of it. If things change in a leaching operation, it is very possible to lose everything that you've been doing up until that point. Very expensive. Leaching is your most expensive operation that you can do in a mining operation. The next one down from that is amalgamation. Amalgamation is got this mystique about it in that all you have to do is add your mercury and your gold, it gets together, and then you've got your gold. It is not under any circumstances that easy unless you are one of the 1% out of the hundreds of operations that are out there. Amalgamation, three basic things have to happen. Your mercury has to be clean, your gold has to be clean, and they have to come in contact. And those are the three basic things that have to happen in amalgamation. Not easy to do. Under most circumstances, your mercury gets dirty very quickly. 50% of the time, your gold is dirty to start with, has organic oils, will not amalgamate. And it is the next technically intensive operation. Just because now, if everything worked right and you've got your gold and your mercury, you're not done. You now have a complete new operation to get your gold back out of your mercury and clean up your mercury again. For hazardness, I would say probably mercury is your most hazardous operation. You have a potential problem with, if you're using heat retorts, of putting a lot of mercury fumes into the air, very poisonous. People die for that kind of thing. So that's your next operation for expense. The next one down, I would say, is probably flotation. Once again, it is a technically intensive operation. You need to know what kind of floating agents you're going to be using. Everything has to be basically the same size, and everything needs to be working right. And then you have a concentrate that now you need to learn how to smelt to a final product. We started in leaching, we got to amalgamation, and now we're at mechanical separation. And as more of a happy camper, gravity separation would be the best and the most cost efficient. After that, I guess the easiest would be what you'd have to say was sluices. I knew I'd get to it eventually. Sluices, and actually at part of this you'll see an operation in the Yukon that they're using sluices. And you'll also notice that they don't have a lot of fine gold. It's all fist size, which is nice. Just nice, don't get me wrong. I like that fist-size gold, but it's not something we have a whole lot of down here in this 48 states.
Okay, what we're going to do here is just sort of set up the table so that you can see what it's working at. Right now you can see that you have little brown lines here from me running it just before we started. And I'll turn it on here, and you'll see the waves, and where the waves are is where your lines are. Now when you're getting this set up, this is what you're looking for, so that you have a nice even flow here. You can see how the waves are nice here and they're jumpy here. What that's from is that this distance is too short, because we're going to be running this in production mode and we're just setting it up for looking at that. These two sections here are for a testing process. When you're running production, you'll want to see a little bit of gold in this area, no gold in this area. What that's telling you is you're running maximum production. If you start seeing gold down here, you're going to have to adjust things, slow up your ore flow, or slow up your water flow. Now what I'm going to do is I'm going to turn a little bit of water on, and then I'm going to put a little ore in here, and we can see how it separates. Now the way the water and the ore gets out from this area of the table, it has to go down underneath this trough, or this ripple, and come out these holes. And that acts like a hydraulic pump. Now, we're setting up for production, and you can see how high the water is up here, whereas if you were only running a 5-gallon bucket or 2 or 3 pounds, normally this area would be about right here. Would it be good for me to set that up so you can see that? It doesn't take much of anything. Okay, now you can see how raising the back of this table up brought this water line all the way back up to here. Which is where you'll want it when you're running a 5-gallon bucket or maybe a 2 or 3 pounds to do some testing and find out how your ore's running. Okay, right now what I'm going to do is I'm going to put a little bit of ore in here so that we can see a separation here. Now what we're doing is we're running this, we're going to be making a concentrate here, we're going to have a nice fine line here, our tails continue on. Now you can see how the ripples are nice, the waves are nice and smooth, whereas opposed to in here they're a little rough. This is good. If it looked like this up here, that would be bad. Now we're running clean water continually for this demonstration. In a production operation or under normal operation, the water that is coming off of here, just settle out the majority of the material, rerun it. You can rerun your water. It doesn't have to be clean. It can be dirty. We don't care how dirty the water is as long as it will move the ore. Now, as you can see here, we've got our line right here, and that's what we're looking for. Now, when we're testing, this line is here. When we're running production, when we're actually running it, the 100 pounds that we're going to be running here, we'll be running it through this trommel, coming over here, running into this trough. We will actually run this whole line off the back of the table into a bucket. And this is your concentrate line. As you can see, we just threw a little bit of dirt on here, and we got a little bit of a nice line right there. And this is where your gold is. Your gold is not going to be down in here. This gold is all being forced all the way to the back. The only thing that would be down here is, let's say, if you had a bunch of mercury in your ore and you had large globulars of mercury, they would be down in here, or you had large nuggets. The large nuggets would be down in here. But your fine gold is going to be up here. Okay, now that we see how it's going to be running like this, now we're going to go ahead and set up, and we're going to run it as a production operation. We'll be running it through the trommel, and we're trying to make a slurry and screen our material at the same time and putting it on the table so that we can continue to flow. Okay, now this is our gold line. This is our gold line right up here, and you can see that there's little gold right in here, and that's just out of that little bucket. There were a couple little scoops that we did, and this is where your gold's going to be. As you can see, all your black sands are up here also. If you have magnetics, they're going to be up in here. There's not going to be any gold down here. For production, what I'm doing is moving the trough down the table, closer to the primary riffle. What that does is it gives me my ore coming in will now fall into this bed of ore. And as it does that, it keeps everything fluid, and that's very important. We want a nice fluid bed. So now what will happen is I'm going to also lower the table, and the black line that we did have up here at the top, we're going to move that black line all the way to the back. And we're going to put it in a bucket that we're going to use and then reconcentrate at the end of the day. Putting this tape on here because I hate the noise of them. Now what I'm going to do is lower the back end with the leg adjustments so that we bring that water line just about to here. Now you just turn on our water so that we can see it. Okay, you can see how the water line is moving up here. I'm just lowering the table down a little bit. It'll be, depending on the ore, somewhere between a 1.5 and a 2-inch rise from the back here to the front, and that'll bring that ore to the back here. So that it's level from side to side. And the easiest way to do that is sit here and look at your water line. And right now I have the water line is sitting about right here, which is nice and level. All right, we're going to turn it on and see what happens here. What we're going to do is watch for this line of ore to move itself up. Now you can't really see it there, can you? It's actually starting to move itself up. Yeah, I can see a little bit there, yeah. See here, right here? Yeah. All right. As you can see, I lowered the back of the table, and we had our line was just about right here, and now you can see as it's moving up here. It's the same line that we were doing that little test with. All right, what we want to do is move this line when we're not feeding to where it's almost to the top, because once you start feeding, what you're going to do is you're going to have more ore and more water in here, and that will move it all the way to the top. You have to just play with it a little bit until you get adjusted to set up to do that. But as you can see, your line has already moved up, and here's your goal line again. There's black sands in there and stuff, but there's a little gold in there too. So you can also test small amounts, just like I did, to see what kind of quantities you have. The ratio is for every pound that you run, for each milligram of gold you get back, indicates 2 grams per ton. So you can figure that into your formula. So you can run 2 or 3 pounds or a 50-pound bag, or in our case we're going to run a couple 100 pounds, and we'll see our gold real well. All right. Now we're going to set up our trommel and see where we're at and start from there. We're ready. Start pouring. Okay, here we are. This is what that's all about, is we're running it through a trommel, which screens and make a slurry out of it at the same time. Okay, now, as you can see, it's starting to flow into our trough. Here's our overflow, our tails. And here's our line one more time. It's still here. Now, as we get more and more ore in here, it will start moving this up. At which time I'll pull the plug that's in the center, and then we'll put our concentrates into the bucket. If you had this all set up on an auger that you're automatically feeding, all you do is make sure that the ore was going into the auger properly, and the table would run itself, and that's the best way to do it. Now, once in a while, what you'll do is you just make sure that you're not packing down, and all you do is you stick your hand in there and you feel that the ore on the table, and if your finger works itself right to the tabletop, then that's all you need to know. Okay, now, what we do is every once in a while you check to make sure that your ore body is not packing up in here, which would indicate that if the table wasn't bouncing hard enough, you were running too much water or not enough water. You may have to put some weights in the counterweight, depending on what it is. But what you're doing is just checking to make sure it's not packing. What you're doing is you're feeling with your fingers, it touches the ore body that's on the table, and as long as your fingers go right to the table top itself, then you know it's not packing. And that's all we're checking for. Now, as you can see, that most of our ore is coming right out of here, and that's where we want it. And you just check it to make sure it's not packing. When a table stops, if you stop the table, then you normally will have to come in here and run your finger underneath this bar right here to loosen everything out. But when it's running in production, as long as it hasn't been stopped, then you won't need to be doing that. Not if you have everything set up right. Of course, as a miner, you always are sticking your hands in here just to check to see if anything's going on. Anyway, that's, it's just nature of things. Now you can see back here that our line is now going into our trough, and that's what we're working for. As you can see, we have clean water here, And as long as we have clean water here, we can actually seed it. But you don't really need clean water. You can use dirty water because once everything is set up and running, that's the way it's going to run. Right now we're running about 20 mesh, and that's where our ore is coming out of there, out of the screen itself. It's a lot better if everything is run mechanically and that everything is feeding at the same rate and everything. You get your best recovery when you're doing that, but when you're only running a couple of buckets like we're doing here, you can run it by hand. And if you're not getting any gold out of 2 buckets of ore, you're in trouble. Now, as the table gets heavier with more ore, you have to turn up your bead a little bit more. As you see, we're starting to fill up everything, which is what it's supposed to do. And like I said, you just check in here once in a while to make sure it's still fluid. Now, up here on this line, we can't see our black line that we saw earlier when we were running small samples. The reason is because you're taking off more material. You're not just taking off a couple of an ounce or so out of a couple hundred pounds. What we're going to do is we're going to try and get 3 or 4 pounds out of a couple hundred pounds. 10 isn't too many because you can just throw it right back on the table, get your gold out of it, and take a look at it. You want to be running more concentrates than you would normally do in any other time because you want to make sure that you get all of your black sands, all your magnetics, all of those things that always normally gave you trouble. What you're going to do is you got to concentrate now, and then what we're going to do is rerun it on the table, get the gold right out of it. It's not a problem. The problem is if you don't take enough concentrates and you leave a little gold and then black sands or magnetics, I can't get them out if they're not on the table.